Newton's laws of motion are three physical laws that are the foundation of physics. Isaac Newton, born in 1643, was an English physicist and mathematician famous for his laws of physics, and has been accredited as one of the greatest minds of the 17th century scientific revolution. Newton compiled these laws in his 1687 book, Mathematical Principles of Natural Philosophy. Newton's work formed the foundation of classical mechanics. No work was more important in the development of modern physics and astronomy than Newton's Principia. Newton's first law, also known as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. In simpler terms, objects tend to keep on doing what they're doing. If there is no net force acting on an object, if all the external forces cancel each other out, then the object will remain at constant velocity. If that velocity is zero, then the object remains at rest. If an external force is applied, the velocity will change because of the applied force. For example, a ball at rest will not begin moving unless acted on by an outer force. When the ball is put into motion, it will remain in motion. However, due to the presence of friction and other outward forces, the ball will eventually come to a stop. Newton's second law is the equation F equals ma. The force acting on an object is equal to the mass of an object times its acceleration. F equals ma is one of the most important equations in physics. The unit of force is a newton, which equals 1 kilogram meter per second squared. Newton's third law states that for every action, there is an equal and opposite reaction. A real-world example of Newton's third law can be seen in a car driving down the road. As the wheels spin, they grip the road and push the road backwards. Since forces result from mutual interactions, the road must also be pushing the wheels forward. As mentioned earlier, for every action, there is an equal and opposite reaction. The reaction is equal in size and opposite in direction. The size of the force on the road equals the size of the force on the wheels of the car. The direction of the force on the road is opposite the direction of the force on the wheels. Newton's laws are some of the most fundamental laws of all science and continue to be integral in many aspects of the professional world.